Professor Emeritus at, I think, Princeton. And he has published these 4 books and many many visualization courses draw on these books for examples. There's a lot of interesting stuff in there. It might not be everybody's taste, especially in seminars, but he's definitely made a mark on the Viz field. And so he strives for design excellence. And he's basically, this is a quote from him: well-designed presentations of interesting data are a matter of substance, of statistics, and of design. He's also kind of like, his claim to fame is that he invented spark lines. Those are these little lines here that you can embed in text. So for example, if you write an article about some kind of stock trades, you could directly embed any of those little charts in your text. And so these are now widely used, and he did also patent the term. He is kind of like also known to be a little bit interesting about his stances on PowerPoint. He hates PowerPoint. So there's like this meme from the internet: every time you make a PowerPoint, Edward Tufte puts it. So his point is that you should, before a meeting, hand out like a printed kind of like summary. Everybody should read that, and then you have discussion. So that's kind of like, if you ever have the opportunity to see one of his Viz courses, expect to hear a lot about PowerPoint. So why am I talking so much about this guy? Because he came up also with these integrity principles. The first one is show data variation, not design variation. So like fairly obvious, like your chart should like faithfully represent the data variation, but nothing else. Right? You shouldn't have like elements that are not in the data that deceive or that are not helpful to the message of the visualization. You should use clear, detailed, and thorough labeling and appropriate scales. Clearly, like labeling and appropriate scales are like key things, and we'll talk a lot about appropriate scales today. And then the size of the graphic effect should be directly proportional to the numerical quantities. And if that isn't true, he kind of came up with the term lie factor, that we can calculate how much a chart actually lies. So the lie factor is the size of the effect shown in the graphic divided by the size of the effect in the data. So what does this actually mean? Let me give you here an example. So the principle is the magnitude of the data must correspond to the magnitude of the mark. Here we have a if Bush tax cuts expire chart from Fox News. And so right now the top tax rate according to Fox News is 35%. And then after the tax cuts expire, we are at 39.6%. So is this a good chart? Why is it not a good chart?
It doesn't start at 0.
It doesn't start at 0, yes. I would even actually say that that's a reason, but the real problem with this chart is that it doesn't faithfully show us what the deviation, what the gap between the two is. It kind of like overemphasizes the difference that we would experience. So how can we calculate the lie factor here? We have the effect in the data is a factor of 1.14, the difference here, and the effect in the graphic is a factor of 5. So we have the lie factor at 5 divided by 1.14, so 4.38, and that of course should be 1. So clearly this is a chart that deceives. So here's an example when somebody has redone this chart and shows us how this looks like if we actually started at scale 0. So we have 35% and 39.6%, and we see there's a change, of course, but it's not this massive change that Fox News wanted us to believe there is. This is a chart from an Austrian tabloid. So this is maybe take a look at it. It basically is about, there's something like a basic income, like an emergency basic income in Austria. And this tabloid is a little bit right-wing populist, of course, and they kind of are trying to tell us who are the people that get this basic income. And it basically starts out with Austria, unknown, Turkey, Serbia, Syria, Afghanistan, Poland, and so on. So this is the lands or the countries of origin for people who get this basic income. So anybody spot any problems with this chart? What are the problems? The leftmost bar goes off the chart, yes. They did label it. It says 100,000. And so if we fix that for them, This would be the chart, but it doesn't yet fit on the slide. So basically, this like the first part here is like how many Austrians do get this basic income, right? And that is completely off the charts compared to the rest of the chart. And clearly, they did put the number in here, right? A very like a reader that really takes care might like pick up on this, but the message at a glance, like what do you ever communicate at a glance, is clearly way distorted. So that is really a very good example of how to lie with charts. Here is an even more extreme example. Again, Fox News, always good for the question is, there's the paradigm of starting scales at 0, right? And that makes sense in some contexts, but it's actually a little bit more nuanced than that. So if you want to tell a story, like the median household income in 2010 inflation-adjusted dollars, if we do this in absolute numbers, we kind of like have this measly effect that we see here around the financial crisis, right? So we see that there's like a drop in median income, but if you think about this, like a $3,000 drop in median income over a couple of years is a big deal. And so this chart might not be like accurately representing this big this big effect. And so in this case, it might be better to actually have a chart like this that starts at some reasonable baseline. But what that is always a bit tricky to do, and it's something that we have to be very mindful of. And so what I really want to say here is to use a baseline that shows the data, not the 0 point. Like the real question that you need to ask yourself if you plot something, is there a meaningful baseline? What is it? Does it have to be 0? We talked about that 0 is arbitrary in some cases, right? So for interval data, starting with 0 doesn't make sense in the first place. So really, this is the question that you have to ask yourself. What is the meaningful baseline to plot the data? Here's like a nice video that Vox did on this topic.
And of course, charts of axes. And pretty much every time we run a chart with a y-axis that starts anywhere other than 0, someone winds up emailing to complain. See, there's a really famous book called How to Lie with Statistics, and it contains a discussion of how you can create a misleading chart by messing with the y-axis. And it's definitely true, you can do this. Here's a chart from Fox News, for example. It's a total disaster. But the y-axis dogmatists take it way too far. The big problem with people who lie with statistics is that they're lying to you. It's true that misleading charts are one way to lie, but the English language is also a tool that can be used for lying. And that doesn't mean we should never speak English. Sometimes you need to fiddle with the y-axis to tell a story properly. So for example, right now, the share of American adults who have a job has fallen to a generation-long low. It's a really big deal. But if you chart this data with the y-axis 0, you can't see the change at all. Narrowing the range to drown out just talking about isn't lying with statistics. It's emphasizing what's relevant. The way Edward Tuck puts it is you need to use a baseline that shows the data, not the 0 point. And after all, 0 is just a number, like any other. Sometimes to make sense of data, you need to be able to show numbers that go below 0. Halting at 0 in those cases doesn't make any sense. But extending every chart label as equal would be crazy too. And of course, where 0 even is depends on the units you're using. If you do a chart of a person's temperature in Fahrenheit, you're likely to miss the fever if you zoom all the way out to 0. If you redo it as a Celsius chart, it's not quite as bad. But if you switch to Kelvin and extend everything to 0, then the charts become useless. When people are really lying with charts, the main thing they're normally good for is leaving out the context, not leaving out the 0. Go back to that Fox News chart. You never know from this chart that the top marginal rate was 39.6% back in the Clinton administration, or that the Reagan administration was 50%, or that back when Eisenhower was president was 91%. The missing 0 was really the last of that chart's problems. What they left out was the entire history of taxes in the United States. So just remember, y-axis don't lie to people. People do.
So what this video also got a little bit at is framing is the key. like this, as any other like tool to communicate, including language or statistics, can be used to lie. But really, what you have to think about is when you want to show something with visualization, make sure that you're faithful to the data, and you might have to take a much broader look at the data to eventually pick a subset of it to show, and you have to make sure that the subset that you're showing is kind of consistent with the rest of the message. So here is another example. This is a chart that you sometimes see about global warming that basically shows us, oh, if you just look at these last 10 years, there doesn't seem to be like a major trend in uptick in temperature. So like nobody would say this looks like a ton of temperature, and I don't want to dispute the facts of this chart here, but what they have left out is again like the longer term context, because if you actually plot this over many years back to the 60s, you start seeing it, right? Like what they were charting here in this upper right corner is just not enough to kind of depict the trend in something that varies as much as global temperature. So here's another example of what not to do. Like there's a couple of things wrong with this chart, but what is the most obvious one?
How come it jumps from? Yeah.
Anybody want to? Yeah.
It's not even like, it isn't even a standard time. It goes into the future and then back to the past.
Yeah, it is kind of like sorted by magnitude. But whenever you do time, you really want to show time in sequence. Right? This is kind of like the basic assumption that people make. If you show time in a chart, that the time is linear. It doesn't jump around. So clearly here, and then there's other things like the 3D effect that they use here, but we'll talk a bit about this stuff later. What about this chart here? It's a little bit more subtle.
How come it's different months?
Yeah, it's basically job loss by arbitrary quarter, and not in any way scaled by time. So if you did this by correct time standards, you see that there is this nonlinear effect in there, which is just absolutely not evident here. So these kind of things that happen a lot when people use Illustrator to plot the data and then simply just make the chart that they want to make to illustrate something, but are not really doing data visualization with this. And this is one of the most extreme examples of using time wrong that I've ever seen. Republican Party presidential primary schedule, and so here you have the day of the month as height of the bars, the states and territories on the x-axis, and the month is color-coded.
What?
Clearly, this is a humorous example again, but why would you ever do that, right? Just make sure that you pick a chart that and axis and scales that they really work with the data. And in this case, you probably want to make a calendar view or something like that. The thing is, though, that I can use really good visual encodings wrongly and then deceive still. So, question here: of those two values, A and B, which one of them, if this were to visualize the mean of a distribution, which one of them is more likely to be in the distribution? B. Everybody agrees? Well, if we actually plot this, there's a line here, and I move it up, it's exactly the same distance. And so, if you think about this, the mean of the distribution means that you have variation. And the bar chart here kind of emphasizes, kind of exhibits what we call the within the bar bias. So if you show a distribution like this, people will always assume that the data is within the bar. And so this is a well-studied effect, and so therefore you should never actually use bar charts with error bars if you ever report on some kind of statistical observation. That's very common because it's easy to do in Microsoft Excel, right? But it's really not the way you should be doing it. So we can plot the data faithfully, but still perceive it wrongly, so we have to be aware of these biases. What about this representation here? Would you have said, now you know everything about this chart, but would you have said A or B is more likely to be in the distribution? Probably not, right? Because you're not being biased by the bar, you just see the median line here. So this is from results from a paper that measured this within the bar bias by essentially showing a couple of different variations of these bar charts and then one time like only the median with error bars, like in stimulus D. And what you can see here is that that the results were clearly biased for all of the examples except for the interval-only example here on the right. So this would be kind of like what you would expect, and then you have the bias in these charts. So like it matters a little bit in how you design this chart. So basically what they were testing here is that a less prominent bar, as in this case with no outline in the light gray, has less bias than like a strongly visible bar, but still this is much weaker, the results, than if you just showed the median plus whatever error bars or 95% confidence intervals, whatever they're plotting here. So here's another reason why you shouldn't do this kind of stuff, because you also, like, even if you just did this like mean plus some kind of confidence interval, you could be missing pretty important things about the underlying distribution of the data. So like what happens, like these are essentially similar bars with distribution. So you would kind of like say, well, this looks like they're all the same, so it doesn't really matter. But what we're kind of missing here is that we have like a bimodal distribution in the green case, and then this like skewed distribution in the red case. And only the blue one is, you could argue, faithfully represented by this particular bar. And we'll talk more about these kinds of things when we talk about tabular data. But the point here is that you have to be really careful when you create representations of aggregated values. So again, it is okay to use something like the median and the confidence interval if your data is roughly normal distributed. So then it's fine, right? But you need to check that. And if it's not normally distributed, if you have some bimodal distribution, you should really like make sure that your visualization shows that. So another thing that like we as humans are pretty good at is like spotting regressions by eye. So there's a paper, regression by eye, that I will be talking a little bit about, and this is also related to the within the bar bias. So like if you give this as a stimulus to participants and ask them to fit a regression line, it turns out that they're pretty good. Like we as humans are really good at fitting these regressions by eye, and that also holds for like quadratic or any trigonometric regression lines that we could plot here. So we're good at spotting these kinds of trends. But then this paper looked at, is this something that we can do with every visualization technique? And they tried 3 different things. They tried here the scatter plot, as I'm showing it here on the left also, then this line chart, and then this area chart. So based on what I just told you earlier about within the bar bias, which of those 3 is not going to work out all that well? The area chart. Yes, they did actually show that the area chart here also results in a pretty significant signed error, whereas the other 2 had a much, much smaller error. So it matters which visualization technique you use because of these kinds of biases that appear. Now my 15-minute rant about pie charts. So pie charts, like, this is an extreme position, the depth of pie charts. And I'm quoting here from Cole Nussbaumer's blog post in this case. But pie charts are really tricky to use. I'm not saying you should never, ever, ever use them, but you have to be very careful and you have to really think about it, about whether a pie chart is justified. So here's a pie chart that shows us the share of coverage on TechCrunch by certain like sectors of the industry, like general consumer, web, social networks, search, and so on. So why isn't this a great chart?
Angle is harder to perceive than position.
Angle is harder to perceive than position, so we have like an inherent weakness of pie charts in here. Other comments?
Similar colors.
Yeah, we have like, they're recycling colors, right? The colors aren't particularly meaningful here. It's also not important in this chart. I don't need to use color here. Other problems?
Some of the colors are so dark you can't read the text very well.
Yeah, there's not great contrast.
Some of the text is outside, some of the text is inside.
Yes, some of the text is outside because it doesn't fit in the segments. Some of the segments are actually not even labeled. So it's really tricky to like analyze this. And so an alternative would be just to get rid of the colors and to properly label it, but this isn't necessarily like a much better pie chart. Right? So what you could do instead is you could just do a bar chart. And That bar chart here like shows the same data, but what doesn't it show? It doesn't show us this part of a whole relationship, right? So we don't actually know whether this is all of it. So we don't know, or whether there might be some other industry sectors that have less than 1% coverage. And that's kind of like the main reason why people use a pie chart. They want to show these part of a whole relationships. And I think that is kind of like an important thing sometimes, but it's very often much easier to kind of like communicate this part of a whole relationship in like a title of a chart, right? You can say like this sums up to 100%, or you can say, hey, I didn't show other like a couple of entries here because they're so small that they're not important. So yeah, that's like a reasonable like if part of a whole is the most important point you want to make, maybe a pie chart isn't all that bad. One thing that pie charts are really bad at are comparisons. So look at the three pie charts here, A, B, and C. Anybody see any trends?
One is getting bigger.
Yeah, the black one is getting smaller. The red one looks like it's getting bigger over A, B, and C. So we have to, like, sure, we can do it, right? We can sit down and try to analyze this, but if I plotted bars about this, I can clearly see, like, this relationship between the segments very efficiently. So it wasn't completely obvious to me that, like, 5 is the biggest, and then 4 is like just the next biggest, and so on. It's really hard to see. Then that they're all about the same size in B, and then that they have essentially inverted this trend in C. So much easier to spot with these bar charts, even though like the colors that they use here for this example isn't exactly great. Here's like a pie chart that I like. We have the sky and the pyramid, and this is my second favorite pie chart, the pie I've eaten and the pie I haven't yet eaten. Okay, so what can you do instead of a pie chart? Oh, there's like one other rule. If you have a pie chart, the only reason to use a pie chart is if you want to express a part of a whole relationship. Do not ever do this, right? Or use like just have some ratio or some numbers over time and then show them as a pie chart. It just doesn't make any sense. So what could we use instead? And I said these comparisons are particularly difficult with multiple pie charts. So here's a redesign example. This is kind of like data that's probably made up about like some kind of like intervention program in like schools about how do you feel about doing science. And so these guys supposedly went in and like lectured like students in school about science. And they did a pre and a post survey and asked the question, how do you feel about doing science? And so in the pre-survey, it was bored, not great, okay, kind of interested. And what we see here is that like 11% are bored and only 19% are excited. In the post-survey, they asked, how do we feel about doing science again? Same values, and then you have those different responses. And so like if you look closely, we do see that there has been like a big jump in the excited slice here. But so how could we show this differently? So first, you could just like alternatively, if you want to have only this one message that people are now much more excited, we don't actually have to use a visualization, right? We can just say, after the pilot program, 68% of kids expressed interest or science compared to 44 going into the program. That's something that I can efficiently say in a single sentence, right? So that's one of those cases where I might not even need a visualization. But if you want to visualize it, because you want to visualize a little bit more nuanced information, you could do, again, bar charts. So here, you basically, like, one thing that you might not have seen in the pie charts is that the share of bored students actually went up. So some people just were really bored by that particular intervention. But what really happened is that people that didn't really think that much about it and said, okay, went into the excited camp, right? So that's something that you can see from this chart. An alternative, if this part of the whole relationship is very important, then you can use something like a stacked horizontal bar chart. They are also smart here about color coding, so they kind of like visually summarize bored and not great, okay and kind of interested and excited in 3 bins. And we have this before and after. These like are not super popular as alternatives to pie charts for some reason. But they have some of the same problems, right? And they're not quite as efficient as bar charts next to each other, as we learned that it's harder to judge the length of these segments compared to if they are aligned with each other. Here is an alternative that I kind of like, the slope graph. So this here is like a way to simply say before and after I have these points, and then I simply connect these same bins. And here I see this very drastic drop from OK at 40% to 14%. That we saw earlier, but it's kind of like very evident in this trend. And we also very clearly see that the board and not grade camp didn't really change all that much. So now I want to do a design critique and a redesign. I'll just hand out these charts. If you're like watching the live stream, here's the link. You can also use that on a computer or iPad. And let me just hand those out. I would like to do this again in groups. Do an analysis first, and then do a redesign on how to do this properly.
The biggest thing that's happening right now is like, what are the rest?
Hey, you just
Think about like the unemployment to like the economy, like 9%. Then you get to like why would you use centuries? Because if you're trying to look at this, because you would expect that this is like yeah, this would be like 4 to 5, and this is like 1 half. So
are these two charts related? I mean, they
I think that we're meant to keep that, especially that line.
because really what you should do is probably either stack line chart or functional line stack line chart. Because you look at here, right? That's what I'm doing. That's not it. And then you have proportions on the
So thinking about reselling, it might be like, what are the rest of them? 4, 5, 87%.
yeah.
Is there nothing under 8%?
well, in 2004, it looks like we're going to come from
What do you think? So we also
No, it doesn't matter. I mean, it's 6 plus 7 plus 15 plus 12.
question, given enough of these morons, there are morons. Probably like yeah, I still don't like it. Like, sometimes they have a color combination that white and orange is too.
I think
Overall trend, economy I still don't like it. Like, I still can't even like tell what it's
You know the few stacks of questions in bar charts you showed earlier? Yeah. Because it doesn't show like the change. Are they typically parts? I also don't think it doesn't really work that well. Like what happens? What if those like handful students go from like hated it all the way jumps up? Or if we get like early deceptive, like we can have a whole chunk of stable light just drop all the way above and then do it all the Yeah, no, that's why I think it's like it's the most common sided alternative for a pie chart, right? But it's not always the best one.
I think the line is
Well, you can have the
yeah, I want a stack bar. I like a stack bar chart to be too have like a circle would be like 100%, and then keep the colors and say, this circle, you got circle here, see like how much the water is, and like this would be red, this would be black, you have to have one for each year.
Okay, remember to spend some time on like redesign, and I'll ask a couple of people to come out and share what we did on the camera here.
So do you have to plug this into Excel?
That's it?
It's like if you have the data, just plug it in Excel and then you're done with like
Sure.
10 seconds.
But you're like Excel also limits you on what you can design. But it's
Yeah, this is kind of boring data. This has like nothing interesting inside
It also
it.
nice to have like
okay. So let's talk a little bit about this first before we look at the redesigns. So like, what are the questions that this visualization tries to answer?
Most important issues to the public.
Yes, and these issues are unemployment, economy, crime, and race relations. Okay, so what is the data that that is represented in these charts?
Looks like survey results for the percentage of people answering the survey that said that was the most important thing to them.
Exactly, and
In that year,
yes, in each year. So over time, so we have like a longitudinal survey here. So how, like, basically we have the like 4 time series essentially, and like how is this now visually encoded?
it looks like the percentage is represented by the radius of the circle.
Yes, the percentage is represented by the radius of the circle. Is this a good idea? Why not? So if you encode data with shapes, we always said like you need to encode it by the area and not just by the radius in the case of the circle here. So clearly that's a problem. What are some other problems about this chart and this encoding?
2003 is a fun case where they're exactly the same and they have to come up with a new strategy.
Exactly. So see how 2003 here, where it's 9% both, they have to do like an exception for that and show it differently. Just from like a bias perspective of stuff that we talked about in this class, do you see any problems here?
They're not comparing the top and the bottom, even though these look like they came from the same survey.
Yeah.
They're separating out.
Exactly. So why do they like facet it out like this, right? Why don't they pick some visual encoding where they can show all of them simultaneously? Because those are all like on the same survey, and we actually have like issues that come up significantly. So it's not really just the first 2 and then the bottom 2, the first 2 and then the 3rd and the 4th or something like that. So what are like other problems?
Even in the years where they've got the biggest circles, they're representing 61% of the data. There's like lost 39% of the data even with those big circles.
Yeah, so we're missing context. There's a lot of other stuff that isn't really shown here.
What's the difference between unemployment and economy? It seems like they're just the same thing, just in different words.
Yeah, you would need a better label to kind of like describe fully what it is, right? What they mean, what they measured, what the questions were.
When they facet it, they kind of like move the x-axis and warped it. So like the amount of data in the top row and the top graph is different from the amount of data.
Yes. Another thing that I worry a little bit about is like, in this case here, for example, I'm showing like by showing the stuff on top of each other, you kind of like potentially like these judgments might not be independent anymore, right? So you might be like see more blue here than is warranted and might underestimate the size of the red ball because they're overlaid on top of each other. So anybody want to come out and share their redesign? Volunteers? Yeah, please.
Does this put it on the computer?
You draw on top of your computer? What?
Yeah. Yeah.
Okay. So my initial thought was just to do, again, with time as the x-axis, to do like stacked horizontal, and with obviously another category. And then the second thought we had was to do line charts, again, across time, and with the option possibly to like click on the other and have it break out into the more like subtle categories.
Cool. So what's the benefit of line charts here?
You can actually see the variation for each concern over time.
Yes, and you could also see do all four of them in the same chart easily.
Yes.
Right? So, thank you. Great. Anybody else have any different solutions or something that they want to share? Yeah, please.
So ours is almost the same thing. The line chart.
Yeah.
We had added bit on it about having perhaps an illustrated timeline underneath. It seems like this chart is designed to get people's attention because it's like circles is a thing that gets your attention when you're scrolling through the feed. So if you were to add back in some kind of attention grabbing feature, like an illustrated timeline underneath, for example,
Yeah.
that could make it like that could keep that aspect of it without having to do it.
Yeah, I think that's a very good point. I think that is actually an important thing here because if you look at this chart again, there is something that happened in 2004, really, that really like is a massive outlier. Suddenly, from 2003 to 2004, crime really jumped as a concern. So we're like not being from New Zealand and not knowing the like history of what happened around this time there. It would be quite interesting to see something like that. So if you show a chart like this and you have this massive effect, you should also give a little bit of context why that is actually what you see. Okay, so here's a redesign that somebody else has done. So first, like we all saw or identified correctly that the quantities here are encoded by diameter, not by the area. And so if I did do this by area, then we can simply fix that, and that would be this representation. But as we also like discussed, this isn't necessarily the best idea in the first place. So just for reference, this is like how it looks like in the original chart here, and this is how it looks like in the fixed radius chart. So you can actually see that there is this 1% bubble is actually much bigger than you would have expected. But is this the visual encoding appropriate in the first place? And I would argue no. And so you can very simply just do a line chart, as we just also saw in one of your sketches. And that shows the trend over time. I can easily put a fourth one on here. There aren't really any challenges to doing a line chart because they're all on the same data scale, right? So I can put them on there without any drawbacks. So that would clearly be a better visual encoding. But why do you think they didn't do that?
Boring.
Because it's boring, yes. And so there's always this trade-off between are you using the most accurate encoding and absolutely minimizing your kind of illustrations so that you're faithful, or are you trying to grab somebody's attention? And we'll talk more about this today. Any other comments about this before we move on? Yeah.
So for me, the white and orange at the top, and then using white and orange to label each of those things, but opposite, is a little confusing about which one's which.
Yeah, that's a very good point. I didn't even notice that. So that is clearly not a great idea, right? You want to pick a neutral color, or at least a color that the object contains. Cool. So let's continue with some visualization design principles. One visualization design principle that also goes back to Tufte is this maximizing data to ink ratio. So I should basically create minimal charts that use minimal ink and therefore maximize the data to ink ratio. So here's an example of a 3D bar chart with lots of extraneous information. Why is 3D complicated, or in this case bad? Yeah.
Depends on your perception of where your
projecting that three-dimensional height onto that sort of a
Yep.
background.
Exactly. So can anybody tell me the value of this bar?
About 600.
Is it above 700 or below?
Below.
Below, maybe. We're not sure. We can simply do it like this, right? So it's exactly at 700. That's like a much better representation. Clearly, you do not need any of those drop shadows. You do not need the 3D effect. This doesn't need to be solo and rendered in a complicated way. So, like generally, like one message is to avoid chart chunk, and I definitely subscribe to this as far as a chart like this is concerned, right? So you do not want to show like clutter your view with stuff that you don't need. So, for example, here you have all of these grid lines. And the grid lines for the percentages could be kind of justified, but what is the point of the other grid lines? Right? So I could simply take off those grid lines and I have a cleaner chart. Do I need a background, or can I take that off? Do the axes on the right actually help, or could I take those off? Or could I do like a completely without axis here, without an axis line, and create a chart like this? And if you just like judge by the aesthetics, I would guess that most people would agree that this is a nicer chart than the first one that I started out with, and it still is absolutely faithful in representing the data. So clearly this is a way to do this, but then there's also things like that, right? Take a look at this chart. This is from Nigel, like an illustration by Nigel Holmes, who did like many of these newspaper illustrations. This is Diamonds Were a Girl's Best Friend, about a drop in diamond prices in the 80s. And so here we have a chart where this line like juxtaposes with this person, and then here we have the alternative. So which of those two charts do you prefer, and why?
Oh, do we care about the data or not?
Do we care about the data or not? Yes. So you could make an argument that this might be like more difficult to interpret, right?
I like the one on the left better because it's more fun, but it took me a second to realize it was a chart. So
yes. So clearly, it takes you a while to realize it's a chart. Other comments? Yeah.
It's good at making a point, but because of the perspective of the image, it's kind of hard to read. So if you just want to make the point that it went up and then went back down, then it's okay.
Yeah.
Just kind of distract you away from what actually you want to see.
Yes.
I have a different opinion from everyone else's spoken. I think the chart on the left is awesome. Specifically because the point is that it was higher and now it's not. So reading it specifically is not super important. This was published in like a newspaper where they're trying to tell you this. And it gets your attention.
Yes. So memorability, that's a very good point. So you get, like, it grabs your attention, it is engaging. Question is, what do you think if I like ask people 5 days later, whether like after they've read this, to summarize what the context of the visualization was and what the trend of the data was, which one will win?
Yeah.
The left one. And actually people have studied this. Here's another one. Which is better? The left one here, monstrous cost about Senate and House expenditure, campaign expenditures in millions, again from the 80s. Here, like an illustration by Nigel Holmes. On the right, like a base R plot that just shows the facts, nothing else. Same problem, right? It's not really, like, this isn't super accurate to read, but maybe there's something about this chart that makes it better. And so there's this paper, Useful Junk, the Effects of Visual Embellishments and Comprehension and Memorability. And that was like a big deal back in the day when this was published, like 5 years ago or 6 years ago, because before then everybody just like, well, not everybody, but there wasn't really like evidence that these chart chunk things are actually like beneficial. And they studied this. They studied essentially how do people perceive them, how accurately can they read them. They picked these Nigel Holmes charts to do that. And then in their experimental results, they did actually not find any difference in interpretation accuracy. They did not find any difference in recall accuracy in a 5-minute gap. So if you see the chart 5 minutes later, what's in the chart? No difference. People like just do it as well with both of these charts. There is significantly better recall for the Nigel Holmes type illustrated charts of both the chart topic and the details categories and trends after like a long-term gap. So these people like, did this study and then asked people to come back 3 weeks later to do a follow-up survey. And participants saw value messages in the home chart significantly more often than in the find chart. So clearly there is a story and there's an agenda, there is some kind of like personal spin that a reporter or an illustrator brings into the homes charts. And they found the homes chart more attractive, most enjoyed them, and they found that they were easier and faster to remember. So there's this kind of like tension. Am I trying to be faithful, or am I trying to, well, you can be faithful, but do I need to be completely neutral in my presentation, right? And so do you want to use chart chunk? Of course, it depends. Pros is you could use it to persuade, you could make a point. It leads to better memorability, and it will likely lead to more engagement. Cons is, of course, persuasion also means that you have an agenda and you might get into like the biased territory. It's also not completely clear whether people would consider the data as trustworthy if you used any of these kinds of illustrations. You have to worry a little bit about interpretability because like clearly these are not standard charts. Space efficiency, and I think one thing that's also quite important is effort. So like you probably would not like a homework where I ask you to implement this in D3, right? So this is like something that is very like tailored specific. You have to really take care of like put the effort in to create that. Any other comments about chart chunk? Okay. Great. So another thing that is important is alignment. So this is here a chart from PolitiFact that analyzes how many like true or false statements these various politicians make, and they have like 6 categories from pants on fire lie to mostly true and true. And so this is a chart that like works fairly well. We see like Trump and Bachmann, not surprisingly, lead the lie category here. But what could we do better in this chart? Like what is not so great? Yeah.
We don't have any idea of the quantity for each individual.
You don't have any idea of the, like how frequently they're checked? Yes.
Could you? I mean, like I've lined it up through the middle of grades.
Yeah, exactly. We have like a neutral point, right? So we have like basically here we have a scale where we have a meaningful 0 in the middle, and so maybe this is how we should line it up. And so this is just a quick illustrator fix of this. And so this is the same chart, just like photoshopped to line up by half true essentially. And now we have both the length of the bars and the positional encoding in both directions. Right? So we can actually, like this is probably a better chart. It shows the data in a more like accessible way. It kind of emphasizes the key point here because we have this neutral point in the middle.
It's really half-truth in the middle.
What's that?
Is half-truth really the middle?
Well, by politician standard maybe. So we talked about 3D a little bit, but like a couple of like formal reasons why 3D is a problem. First, we can go back to Stephen's psychophysical power law and look at depth perception, and we see that depth perception here is actually like we tend to underestimate the depth of something. So it's not a linear relationship. So compared to length in 2D, depth is much harder for us to perceive. So that's one reason we can't really judge the length of objects in 3D. 3D also leads to occlusion. If I have a 3D scatter plot, I could have like some point simply obscuring them completely, obscuring some other points completely. Because of the way, like we don't, like if we show 3D charts on a screen, it's not actually stereo, right? Like we have stereo vision that helps us perceive 3D. And because we don't have that, we usually have to do like emphasize things like lighting and shadows and shading, and we need to like have a vantage point in 3D, or we can choose a vantage point. And all of this also influences how accurately we can draw data. So for example, if we use lighting and shadows, then we can't properly use colors. Another problem is that if you have 3D charts, you want to label something, right? And then tilted text in any way is illegible. So you can kind of avoid this by billboarding, but still that's a problem with 3D charts. So just don't do any of those things. Like it's pointless, right? So this chart here is not useful. This isn't completely terrible, but I don't think this is good chart chunk, right? This is just some like graphic effect, and clearly here this is horrible. Like there's bananas in the background, but everything else here isn't particularly useful. And an even more extreme example of a 3D that I found on this website that is WTF Viz. So don't actually do anything like that. That doesn't make any sense, right? The multiple pie charts here don't show some different data. It's just the same thing over and over again. So what are the design alternatives? Like I could do something like these 3D bar charts. These pictures are from Daniel Alves' paper that I pointed to earlier. So here we have like 3D bar charts. What we should do instead for, especially when we represent the distribution, is something like this, right? Like a mean plus some confidence interval. That would be like a simple design alternative. If I have a chart like that, what can I do instead? I could do, for example, here, use these kind of like the size of the rectangles to represent the size of these bars. Or I could use color in that case. So these are like examples from some bio paper about cells. So clearly, like this here is legible, or those both here are legible. The left one here is barely legible. Which of those two do you prefer? And why? Any opinions?
The top one, because you get the area encoding, you can see it.
Yeah, so you get area encoding in the top one. You can see it a little bit better. Yeah, I have to say I have a hard time judging. Probably I would go with the bottom one, but it's not. I can't really give you good reasons. It's maybe a little bit more familiar to readers to have these heat map style representations for data like this. This is an actual paper. Like some of these figures that I show you are from sites that are not necessarily like recruitable resources. This is a visualization research paper from 2002, and this was like back then when the visualization field didn't really wasn't mature enough to really iterate through and develop those design guidelines. And so it was a little bit more, let's say, what can we encode instead of what should we encode. So this is actually supposed to show you a tree hierarchy. The biggest beam here at the back is the root of the tree, and then the ones stacked, like you can see some of that here. Like this is the root, and then these are the next level ones, and then they stack it again on top of that, and so on. So it's a deterministic encoding, but it's not readable, right? And so back in that time, you could actually publish something like this just because you had the idea. It couldn't be encoded like that. Of course, the field has changed a lot since then, and we don't see examples like this too much. And I have to say, though, that those two people here, Frank van Ham and Jack van Wijk, who published this paper, are both exceptional researchers. They do a lot of great work. But back in 2002, they were the first 3D capable computers that were commonly available, and they just did stuff like that. And there's lots of historical examples that use 3D in a nonsensical way. One other rule that I kind of want to talk about today is eye-speed memory. And what I want to say with this is do not try to make people memorize. Show them. So here we have a chart of US and Japan fertility over time. On the x-axis we have the fertility, the age, the average age, or the age at which women give birth. So you have like this distribution of at which age do women give birth, and then on the y-axis we have the number of births per woman. This chart is actually a video that shows us this data from the 40s up to now. And just pay attention, and then maybe I'll ask you what you see. Okay, and start it again.
Yeah, so people are having children later and fewer.
There's fewer children per woman, and they tend to have them later. It's not a terrible chart, right? It follows all of the guidelines that I talked so far about. It encodes it by position under every data point is positioned under the curve. We juxtapose those two curves here. They use faithful scales. So everything here follows the guidelines that we talked about so far. But still, it's pretty hard to read. And why is it hard to read? Animation, yes, it's a video, right? You do not, how much has it changed from 1940 to 2000? It's not that obvious to see that. It's not explicitly encoded. You have to watch the video, pay attention, selective attention to a feature that you want to observe, and then spend time watching this whole video. So what could we do instead? The standard solution, if we have something like this, would be, well, maybe we should just do something differently by showing it small multiples. And so here would be this chart if we had faceted it out and show every single year that we show in this animation frame. So is this a good visualization?
No.
Why not?
Small.
Small, yeah. So if I give you a printout that has just this visualization on it, it might be okay, right? You might be able to spot some things, but on this presentation, you can't even see the labels. So clearly, the question is, for what do we need this chart? And do we really need to see the difference between 1972 and 1973? Maybe we don't. Maybe we can have a coarser scale, right? So we can kind of aggregate and get rid of some of them. And so here is kind of a summarized version. So fertility in US, Japan again. We have now only a couple of charts that are binned according to decade, essentially. Or 47, 1950, 55, 60, 65, every 5 years. So is this a better chart? I would say it's a better chart. But the question is this the first, should we show that like this in the first place, or should we do some data transformation first? So we can actually simplify by just creating two different charts. And in this case here, we are showing separately the total fertility rate in the US and in Japan on the left, and then the average age when giving birth in the US and Japan on the right. So this clearly shows us the fertility rate kind of dropped in both countries, but dropped faster in Japan around 1950. And we see that the trend is exactly the same in terms of or almost the same in terms of the changes, but the absolutes are quite different for the average age when people give birth. So I would argue that these are very efficient charts that communicate the data of this previous animation. And so just faceting and showing it multiple times is not always the solution. Very often you can simplify it. And so here is another example. Here we have a scatter plot of 3 different a time series data where we really care about both dimensions in some way, from 2010 to 2012, a couple of companies. Why isn't this great?
It's hard to.
It's really hard to track where the points moved, right? So you have to take care and look at the green point. It moved a little bit, and then here it moved a little bit. So here are 2 design alternatives to that. So here they, in this case, they used slightly different shades of the color to plot them at the same time. And here on the right, they showed basically a trace of how this point moved in this 2D chart. So what do you think about these 2 design alternatives here?
It's easy to read the change on the one that's on the right.
Yeah, it's pretty easy to read the change. It's also not that hard to implement, right?
Superposition seems like it would only work if you have a couple data points you're trying to visualize. You have 2 metrics and it's too flat.
Yeah, so you kind of triplicate the points in your scatter plot here, right? That is a problem. But you also introduce more clutter here. So if you have a really lot of data points, both of these strategies might not be the best, right? So then you might have to do a different approach altogether. But for these like sparser examples, these are like pretty reasonable design alternatives that make this reading this a little bit easier. Okay, that's it for today. We'll wrap up a little early, and I'll see you guys on Tuesday when we talk about maps.